Hi, here's another one that is a little bit different. I'll even show you my solution in a minute. I would have not thought of this in this way, thinking of it as a sum of expected values. I would have built a mass function for the situation and then found out the probability of, found the expected value of that mass function. So I'll show you theirs, and I've kind of written out the solution, and then I'll show you what I was thinking. And you can see sometimes I just don't think in these ways. A box contains 9 light bulbs. So let's change color now. It's not a hard decision. Let's do like this greenish color. So let me see, a box contains nine light bulbs. So here's a box. I'm actually packing my house or my apartment because I'm moving this week. I just bought a house, so I see a lot of boxes everywhere now. I'm on a box hunt. Anyways, here's a box. Contains 9 light bulbs, so these light bulbs are just right in here. Okay, so you get the idea. There's light bulbs. And 2 of them are defective. Okay, so maybe you don't know which one. Maybe that one's defective and that one. And again, there's a bunch of other light bulbs in here. So 2 of them are defective. What's the expected number of light bulbs that you'll have to keep testing until you find the 2 defective light bulbs? And you're pulling them out randomly and without replacement. So, once you pull one out, you test it. It's good or bad, you don't put it back in the box again. So, when I first thought of this problem, I'm thinking, well, hypergeometric because you're sampling without replacement. But then kind of a negative binomial because you want to know number of trials till your rth success. So it's kind of a mixture of those things for me. And I'll show you when I build my solution that's the way I built the mass function. But they're going to do it this way. So let I equals 1 through 8, and j is going to be bigger than I. So I and j are just indexing variables. The random variable xij equals j if the ith and jth light bulbs are defective. So in other words, like if the first and fifth are defective, then x15 is going to be equal to 5. That means I've had to test 5 bulbs. Right? So you're going to test 1, 2, 3. The most you could have to test is all 9 of them. So, for example, if you found it on the 2nd and 7th, then x27 is equal to 7. That means you had to check 7 before you found both defective. So that's how they're labeling their random variable there. And let me see. Otherwise, xij is equal to 0. If the first 2 bulbs are not defective, then x12 is 0. So in essence, then, if you sum up over all the xij's, then this is the number of light bulbs to be examined, because this is either going to take on the value 0, or it's going to take on the value j, where j is where you hit your second defective. So expected value is just the sum of all these expected values. So this is every case we could have. For example, I want to write it not for like x of 1, 2 plus x of 1, 3 plus x of 1, 4, x 1, 9 plus x 2, 3 plus x 2, 4 plus x 2, 9 plus, and there's actually 36 of these. So the expected value of xji is j times 1 divided by 9, choose 2. 9 choose 2 is 36. So the problem with the probability that it's going to be x12 or x13 or x14, the probability x1j is equal to j is 1 out of 36. That's the probability that, that's the option that holds, because everything else is equally likely. So I don't know that I'm explaining that very well, but this is expected value of xji. Any of the xji's, j is the value and 1 over 36 is the probability that that value occurs. And well, maybe it'll make more sense when I show you my solution. And so then you can pull this out. It's just a constant sum over your j's. There's a nice formula for this, right? Once you sum over your j's, and this is going to come out to be about 6.67. So that was not intuitive to me, the answer, how they did that. I mean, yeah, 6.67 makes sense, but for the way I would do the problem, let me show you what I ended up doing. I think I'll go over to Maple too. Let's just choose a different color. Let's go here. I let x equal number of bulbs needed to check to find two defectives. And x could take on the value 2, 3, all the way up to 9. So I figured, I mean, worst case, brute force, I could just write out every probability. It's a little bit painful, but maybe I would see a nice pattern. So P of x is equal to, for example, the first one's easy. The probability x is equal to 2 means you got a defective bulb, which is 2 9s, and then you chose the other defective bulb, which is 1/8. So this is 1 over 36. Probability x is 2, so that was, I thought, pretty nice. What's the probability x is equal to 3? Well, that means in your first two draws you found at least one defective, and the last thing has to be defective, right? So in the first two draws, so 2 choose 1, we found one defective, so this is a defective. And then let me see, there's 7 that aren't defective, and then times the last one you get is defective, which is 1/7. So 2 choose 1. This kinda is like a negative binomial, except you're doing it without replacement, and then this last guy here is a defective. So notice how nice things cancel. So this is going to be 2 times 1 over 36. So x is 2 is 1 over 36, x is 3 is 2 over 36, and you can start to see maybe there is something nice. So the probability you find it on the fourth one means that you got one defective in your first 3 draws. So 3 choose 1, 2 9s times 7 8s times 6 7. So this is defective, non, and non. And I've accounted that 3 different ways this could happen. It could have been the first, second, or third. And then the last guy is defective again, so that's 1/6. Notice again you get this nice canceling. So this is going to be 3 times 1 over 36. So pretty much P of x, you can see what it's going to be. This is x minus 1 over 36 for x equal to up to 9. And then expected value of x is just the sum of x minus 1 over 36 times x from x equal 2 to 9, and this comes out to be whatever it was up there, 6.67. So let me show you my maple. It pretty much does exactly what I said. I was playing around at first to make sure I believed it. So this is a probability that oh, I shouldn't have said 0, but I do it as quickly as possible in 2 draws, so 2 9s times 1/8. The probability I do it in 3 draws, so same thing I was just showing you, 4 draws, 5 draws, x draws in general. You see it should be x minus 1 choose 1. You have to find 1 in the first x minus 1, and the last one was also defective, and then notice every time we just had that 2 times 72. I summed that. It's legal. I found the expected value, so everything is good. Yeah, I think that's kind of interesting, just because I don't tend to think of problem solving them going right to expected value. So I think I'll do one more, or at least state something, and then or just look at it. Maybe we're done. Let me see.